in any organization, and operational decisions are taken which are related to the production and factory growth. And if you can see here the constituents that are involved in manufacturing strategy content model, here we have business strategy, manufacturing strategy, competitive priorities, and decision categories. So if you look at your manufacturing strategy, that is content model, which includes business strategy, manufacturing strategy, and as well you can just look at your business strategy, manufacturing strategy, and in manufacturing strategy, we look competitive priorities and also decision categories. This all will come under the manufacturing strategy when it is taken into consideration. And if you look at your competitive priorities, we means as a manufacturing industry, we'll think about quality, cost, delivery, flexibility, customer focus, and know-how, technical know-how. So, and competitive priorities, if we just look at that are been again precised into quality, delivery, cost, and flexibility. So, in these four criteria, when you look at this, the description is about manufacture of products with high performance standards, reliable and fast delivery of products. And when you look at the cost, production and distribution of the product at low cost is considered, and flexibility, ability to handle volume and product mix changes that are taking place. And when you look at the decision categories, they have categorized into two categories, that is structural decision categories and infrastructural categories. When these points are being kept, if you look at here, structural decision categories, we have process technology, facilities, capacity, and vertical integration. So, type of subdivision, how it is done. Process technology means process choice, what you are selecting, its technology, and its integration. And when you look at the facilities, it is size, place, specialization, and focus. And if you look at the capacity, under capacity, we look at what is the amount that we are investing, and time, and the increment size. And vertical integration, here we'll look at the direction, degree, and balance. And infrastructural categories, we have performance measurement, introduction of new products, organization, and manufacturing planning and control. So if you look at here, these are subdivided into, or subdivisions are taken as follows. They are under performance measurement, we take measurements as one of the sub process you can think, or subdivision policies we assume, and strategies to measure and feedback. And introduction of new products, we have rate of introduction. And in the organization, we have design and style, human resources, competency development. And in manufacturing planning and control, we have system design, decision support, and system integration. And we're talking about the manufacturing capabilities. Here we have competitive priorities. That's what we have discussed. If you just look at, you have a glance over here. This is the manufacturing strategy content model. This is taken as an inverse of that. If you just look at here, it's just inverse of the same model which has been existing. That is competitive priorities, decision categories, manufacturing capability. Then goes the manufacturing performance is been valued. And if you look at here, examples of internal and external measures of operational performance. Here we have operational performance system. Under that we have quality, delivery, cost, and flexibility. Internal performance measures mean these are the basis or criteria they have taken in order to understand the internal performance as well as external performance. In internal performance, we have rework cost, percentage of past quality inspection, cost of quality control. And same when you talk about the delivery, production lead time, accuracy of inventory status, dependability of internal lead times. And next you have unit cost of manufacturing where we talk about inventory turnover, capacity utilization and yield. And under flexibility, we have setup time, cost, length of fixed production schedule, and amount of operating capacity. That is, these all are about internal performance measures. When you talk about the external performance measures with regard to the quality, with regard to the delivery, with regard to the cost, and with regard to the flexibility, we have external performance measures are conformance to agreed upon specification product performance. That is with regard to the quality. With regard to the delivery, we have delivery lead time, on time deliveries, and stock availability. And when you talk about the external performance of cost, here we take into consideration the product selling price, market price, and flexibility, product range, number of products offered, ability to handle volume, and product mix changes. So these are here we talk about quality performance, delivery performance, cost performance, and flexibility performance. Manufacturing objectives and strategic business objectives are to improve the quality, to reduce the cost, to increase flexibility, to improve supply chain efficiency, to increase sustainability. And also we have a table which shows what are the main objectives in Indian industry. If you look at industry, supply based reduction, product quality improvement, on time delivery, manufacturing lead time reduction, linking manufacturing and corporate strategy, inventory reduction, capacity utilization, flexibility of product mix, flexibility of production volume, faster new product development. And also we will discuss about manufacturing management practices. If you see, this is the image that has been displayed on your material or book which is supplied to you, which talks about world class manufacturing pillars. Based on these pillars only, the world class manufacturing, the sustainability or the stability of manufacturing organizations are going based on these pillars only. If you look at here, we have this we have almost 10 pillars on which basis the world class manufacturing is working or going on. The first one is safety, next is cost deployment and focused improvement, autonomous maintenance, workplace organization, professional maintenance, quality control, logistics, early product equipment management, people development, and environment. So these 10 pillars will are providing to have all the manufacturing industries, and these are the changes that have been taken place to get the best products with the minimum cost reduction. So you can just look at these 10 pillars they're given in the table format, which will explain us what's the purpose, why is it done. So if you look at the first one, safety, for continuous improvement of safety measures has to be taken because to reduce the number of accidents that are coming across in the manufacturing industries where the machines are working, and culture of prevention, and also improve the ergonomics of the workplace and to develop specific professional skills. When you talk about the CD, that is cost deployment, analysis of the losses and costs that has to be done, and purpose is to identify scientifically and systematically the main items of loss in the system production logistics business. And focused improvement, here it's to priorities of actions to management the loss identified by cost deployment. Here the main purpose is to reduce the most important losses present in the system, that is manufacturing plant, we have to be eliminated. That inefficiencies has to be eliminated. And focused improvement, priorities of actions to management, that is loss identified by the cost deployment, because to reduce the losses that are been taking place. Next is autonomous activities to continuous improvement of plant and workplace, that is improving the autonomous maintenance and workplace organization. Next comes the professional maintenance, quality control, logistics, and customer service. So these are the different 10 pillars based on which world class manufacturing is taking place. And the next topic is models of world class manufacturing. So, what are the models that are available and or existing in the present manufacturing industry to get the 100% best output with minimum reduction of cost? World manufacturing excellence and world class manufacturing. If you look at the table that is being displayed over here, that is improved manufacturing or improved business performance and world market domination. Can just look at here. This is how it's working. And Hall's framework of value added manufacturing, where different types of waste and their elimination methods have been given by Hall in 1987, which is called as VAD, that is value added VAM, that is value added manufacturing principle, that purge anything that does not add value to the product or service. Better to remove those things. So this was given, which talks about the waste type, that is waste of overproduction, waste of waiting, waste of transportation, waste of processing itself, waste of stocks, waste of motion, waste of making defective parts. So here elimination methods are, when you're talking about the overproduction, reduce setup time, synchronizing quantities and timing between processes. And waste of waiting, synchronizing workflow as much as possible, balancing uneven loads, etc. When, when you talk about waste of transportation, redesigning layouts to make transport and handling unnecessary. Waste of processing itself means need assessment of products and process. And waste of stock, reduce setup times, lead times by synchronizing workflows. And waste of motion, study motion for economy and consistency. And waste of making defective parts, prevent defects to eliminate inspection. Next is principles of value added manufacturing, that is VAM. The main principle, there are several principles, although, but it works on take a broad view of operation, make problems visible to everyone, keep it simple, improve operations before spending on new plant and equipment, flexibility. Next, categories of the framework. Manufacturing excellence through value added manufacturing, that is we have three circles they given, that is total quality, JIT manufacturing, just in time, and also total people involvement. When you talk about total quality control, the total quality control is thought revolution in management. Karo Ishikawa. Ishikawa is the one who given or developed this concept. Karo Ishikawa is Japanese person. He said that total quality is a control is a continuous process or a continual process. Begins with the customer, measure and track quality, take a broad view of quality, set targets for improvement, responsibility at the source is important, standardization and maintains good practice and prevents problems from recurring, and fail safe operations. And if you just look at your JIT manufacturing and also total quality process involves PDCA. That is Plan, do, check, and action. Plan is to determine goals and targets, and do is education and training, check is inspection, and action is take appropriate action. And JIT manufacturing only the right materials, parts, and products in the right place at the right time. Next, look at the total employment. Schonberger's framework of world class manufacturing. So, these are all the different models that are being initiated by different persons by doing research work on world class manufacturing, which was given in 1986. And Gunn's model of world class manufacturing, if you just look at here, it talks about global competitors, quality, strategic vision, world class manufacturing, global markets, customers, management resource, planning, technology, human resource, and quality. Suppliers, product and process design, planning and control, production, distribution, service, integrated manufacturing. Next is Maskell's model of world class manufacturing. So here Maskell is a person who given this model which talks about new approach to product quality, just in time production techniques, change in the way the workforce is managed, and flexible approach to customer requirements, in which they discuss about transfer of responsibility, education and cross training, problem solving and quality circles, production flexibility and design flexibility. And if you look at the next model is Ono's view of world class manufacturing. World class manufacturing here, you can just look at this how actually it takes place, order, timeline, and cash. So you know how many days it's going to be get into cash. And this model talks about all we are doing is looking at the timeline from the moment the customer gives an order to the moment when it collects the cash. And we always try to reduce the timeline by removing the non-value added waste that are been discussed in the timeline is nothing but the time when we are receiving the order till the order is converted into cash. Whatever the waste or non-usable things that are been stopping or limiting the order or converting that order into cash, then the order into cash, that is called a timeline that comes into existence or picture. Next, other pertinent information on that is world class manufacturing. America's best plans, model of world class manufacturing. Malcolm Baldrick National Quality Award. Manufacturing excellence through value added manufacturing. So, if we just look at here, leadership and management of the organization. This leadership and management of the world class manufacturing organization is relentlessly evolving from an operational mode characterized by command, control, and maintenance of the status quo. See, it's better. This is what we call it the break even point. Maybe you're not earning the profit, but see that you're not in the losses. That's what status quo. And also an inappropriate approach to the chaotic environment confronting manufacturers today to a dynamic model requiring innovative leadership, strategic vision, and also radical reformulation of an organization structure and administration is very, very important to get attain or value added manufacturing if it wants it's if that particular manufacturing industry or the company or the organization whichever is moving towards world class manufacturing, in that case, the organization structure has to be reframed. In the process, they have given as per this one. So, if you look at your people, individual and teams, parameter, attitudes, perceptions, and motivation, purpose, for what purpose? The work, participate, or empower, positions, enlargement, or enrichment, or rotation, whatever you are doing with your employees. Next, suggestions, QCs, quality circle, CFT, cost reduction, and also continuous improvement and learning, and motivation that gives you the power that has to be given in the form of rewards, compensations, or some incentives, and career succession or career promotions, and leadership, and the lean manufacturing. So if you look at here, in any organization, without these stakeholders, the stakeholders are nothing but the customers, employees, the investors, or the suppliers, or the vendors, or the management. These all are the key role players, or these are the stakeholders who will be working or will be acting for having the world class manufacturing or valued manufacturing is to be done. Without them, it cannot be succeeded. Desired state map. If you look at here, growth, that is lead time, survive, that is all by following this productivity, weekly refills, operational excellence, customer satisfaction. Then comes the longevity, that is safety. And if you look at here, we have manufacturing excellence and manufacturing culture. So here the present meaning of manufacture and production we will discuss it. The term manufacture originally appeared in 1622, with streaming from the Latin word manufacturum or manufactum. The meaning is production of tangible or material good. So manufacturing is nothing but meaning is production of what? Tangible goods. That is the meaning of manufacturing. So production is, on the other hand, appeared in 1483 itself. That is stemming from producer, that is lead forward, means making something new, either tangible or intangible. That may be service also. So, however, the present meaning of manufacturing has widened into conversion of design into a finished product. So, we use a number of times manufacturing, but manufacturing is from the Latin word, which means production of some tangible goods. We call it as manufacturing. So there are some definitions given. Approaches to manufacturing excellence. So automated production, that is CIM systems, computer integrated manufacturing systems, where we talk about CAD, CAM, and CAP. Computer aided manufacturing, computer aided design, and computer aided planning. These three are playing a very crucial role, or this they are called 3Ks. 3Ks are established to amenity factories through automation. To have manufacturing units, to have an automation, CAD, CAM, and CAP are used. And just give me a second. So CAD, CAM, and CAP, these three tools or these three models are used in the manufacturing units to do the or to make the manufacturing unit as a fully automated, or automation has to be done. Yeah. Now look at the flexing or human centered production. So that is automated production perspective. That is approaches to manufacturing excellence. How to get an approaches? In that first one is to make the manufacturing unit as fully automated, or either you make human centered production. Means technology centered full automation, mainly comprising highly advanced production technologies, may not only insufficiently flexible, but it also characterized by a lack of innovative flexibility, greater vulnerability, and also a lack of innovative flexibility and human skills. Sometimes what happens, neglecting human skills or robbing workers of their pride and pleasure of work. This may make or chance in spite of enormous amount of capital investment, this takes place. So it is the time to give more importance to the human centered manufacturing. So manufacturing a variety of products of super high quality with the use of high technologies, but still drawing heavily on skill of workers, is what flexible manufacturing is, or human centered, or we call it as anthropocentric system. It means no conveyors in automobile assembly factories, Volvo in Sweden, Honda in Japan. These industrial community systems run by craftsmen in Italy. Flexible manufacturing means they use both machines, but similarly, simultaneously, the importance is given to the even to the human person or people. So resource saving and environment preserving green production, recycle oriented manufacturing systems, high added value production. And also, if you look at your type of manufacturers, if you just look at here, services and products, service led producers, product manufacturers, service manufacturers, and system integrators. Next, we move to the block 2, which we talk about manufacturing process, planning, and tools. Under this, we have 4 topics, that is information management tool, that is product and process tools and barcode system, material requirement planning and manufacturing resource planning, that is MRP1 and MRP2, that's management. Material requirement planning is MRP and 1, and manufacture resource planning is 2. The next is just in time manufacturing, lean manufacturing process and application. So information management tools, product and process tools, and barcode system. So how these information management tools are being evolved, what is this barcode system, we'll try to understand. If you look at here, manufacturing evolved considerably since the advent of industrial revolution itself. But in current global and competitive age, it's very important for organization to have manufacturing practice which is lean, efficient, cost effective, and flexible. And world-class manufacturing is a collection of concepts which set standard for production, manufacturing for another organizations to follow. And Japanese manufacturing is credited with the pioneer of concept of world-class manufacturing. World-class manufacturing was introduced in the automobile, electronic, and steel industries also. So world-class manufacturing is a process-driven approach where various techniques and philosophies are used in one combination or the other. So here, what is the need to manage information? Do we need to have any management for the information? Yes, this is because of tremendous growth and heterogeneous collection of digital information. We have to depend on different types of information management process or tools to preserve, organize, and access information to carry out their professional tasks. So here are some of the points or the which are manage information to save time, to preserve information, and to maintain data integrity, to understand and use information in future. So information management tools, here we have product and process design tools, which are used to create and manipulate data on products and process. This includes CAD, that is computer aided design, and CAE, that is computer aided engineering, CAB, that is computer aided process planning, product data management, PDM, and group technology. These are the different tools that are being used and using in the manufacturing industry. So here lean production tools are very often dubbed as Japanese manufacturing techniques or just-in-time tools, such as the famous Kanban, and statistical quality control tools, barcoding systems, decision support, execution and business tools, which are today some of the hottest mantras in the market. That is MRP, manufacturing resource planning, enterprise resource planning, market manufacturing execution system, supply chain management. And also when you talk about the CAP, just look at here. Give me a second. Yes. So if you look at here, first we discuss about the CAD or CAM, that is the use of computers to design and manufacturing process. So what are the products that are coming? What are the manufacturing that are taking place? They design it in advance and then it goes to the manufacturing process. It is concerned with the application of computers to main manufacture of engineering components from drawing to the production phase. So to the machine, to the assembly shops, to the quality control department, and to the warehouses. So the technology of CAD CAM represents an efficient, accurate, and consistent method to design and manufacture of high quality products. So what is the role of computers in manufacturing? You may get it out because the manufacturing is done by the labor or the people or the human resource or the personals. Then what is the use of machines? In this case, the computers had a positive impact on manufacturing engineering. To design any product manually, it may take some months or years, some months, minimum of months. But whereas in system, with the help of computers, now presently with the help of AI technology, with the help of AI and with the help of technology or the computers, we can generate or design with the help. I'm just using the word help, with the support of AI technology and the computers. These can be done within a span of seconds or a minutes. So the first and biggest positive impact of on engineering being the computer numerical control machine, CNC, were first introduced in the 1970s, which typically replace or work in conjunction with some existing manufacturing process. So here it is divided into two groups. One is computer monitoring and controlling all the manufacturing process, and the other one is manufacturing support applications, which deals with preparation for actual manufacturing and post manufacturing. And if you look at here, the example that in chemical process industry, number of process parameters may be monitored. And in second category, if you see the successful completion, for example, use of computers to develop geometric models for all the products in 3D form. If you want in 3D form, that may help. That is with the help of CAD. Use of computers to support basic error checking, analysis, and optimization. Use of computers to generate software to develop the computer numerical control part programs for machining and other process operations. And CAB, that is computer aided process planning, which involves using computer technology for designing physical products. It goes along with the things like computer design and computer manufacturing, but also it also computer process planning, which focus on industrial processes. It's a link between the engineering and manufacturing process. So the process planning can be defined as the act of preparing processing documentation for the manufacturing of a piece, part, or an assembly, or it process planning was done by using a computer is called CAP. So what actually it will do? It will understand the interactions between the part, manufacturing, quality, and cost. Systematically, it produces accurate and consistent process plans. And also, skill requirements of process planners are reduced. And different parts of CAP are GCAP, VCAP, and RCAP. GCAP is generative computer aided process planning. VCAP is variant computer aided process planning. And RCAP is retrieval computer aided process planning. Now, if you see GT, that is group technology. What is the model is group technology. So, what does this group technology talks about? If you just look at here, this is the layout of group technology, how it actually works. It's a tutorial representation on a graph. It is given. On x-axis, it is taken as output or product variety. On y-axis, we have taken as production or operations volume. And here, if you look at mass production type, batch type, job shop type, and production operations capacity, production operation flexibility, job shop production system, batch production system, and mass production system. It varies from one to one, and it varies from the system to system, the approach to approach, how it is being seen in that way. So standard and proprietary, if you, what are the uses of GT technology? This can be used to easily follow a GT technique. There are numerous parts in any assembly if it is there. These various parts can be classified into three broad categories: standard and proprietary parts like nuts, bolts, screws, keys, washers, and similar parts like shafts, gates, bearings, levers, and product specific parts like gearbox, bed, saddle, etc. Next is barcode systems. In this barcode system, this we continue in next class.